Today we'll be talking about linear algebra. What is linear algebra? We always hear about algebra, but linear algebra is a branch of mathematics that talks about vectors, matrices, and systems of linear equation. We just completed systems of linear equation, and it's only right to now speak about linear algebra because now you get to see the matrix method of solving systems of linear equations. And if you're new here and you don't know what we're talking about, check the previous video. Hi, my name is Rose and this is the School of Mathematics Nigeria. Why do we do linear algebra? What do you expect? Why is it important? It helps us solve problems like how can we manage many equations at the same time? How can we represent data in simpler form? When we say data, we mean scores, movements, directions, etc. How do machines understand patterns in data? Machines like ChatGPT, Google, etc. By the end of this course, you should be able to understand the different methods of solving simultaneous equation, which we already did. You have the substitution method, the elimination method. You should be able to know your determinants, eigenvalues, and vectors. You should be able to understand and manipulate vectors and matrices. You should be able to apply linear algebra in the real world. So let's get into it. We're treating matrices. What is a matrix? So a matrix is a set of real or complex numbers arranged in rows and columns. So if you've done computer science, you've worked with Microsoft Excel, you've worked with Google Sheets, you should be able to know what columns and rows are, right? So you could write it like this in a square bracket or in your braces, whichever one is fine, right? But in most cases, we're going to work with this. If you do this, people are going to think that you're working with vectors or modulus. So it's advisable that you use this. How do you identify your rows and your column? I need you to take note of this so you're not making mistakes, okay? This should be your row. And this is your column. You can easily say your row is the horizontal, right? Like this, on this level. These are your rows, okay? And then your column is the vertical. These are your columns. Please take note, okay? Okay. Now this is a 2 by 2 matrix because you have 2 rows and 2 columns. As we go, you would get it. So a matrix is like a table of numbers. So you're given a table like this where you have Musa's test to be this, right? And Rita's test to be this. So you can represent this table as a matrix, okay? Good. Now, we always call the row before the column. What do I mean? Who can let me know what this is? How do we call this matrix? Now you notice that we have 1, 2, 3, 4. 4 rows. Remember, our rows are in this order. And then how many columns? These are your rows. You have 4 rows, 1, 2, 3, 4. Okay. And these are your columns. You have 1, 2, 3. So this is called 4 by 3 matrix. So let's see some various types of matrices that we have, right? The first one is your row matrix. Remember, we said row feels like it's laying down, right? Your horizontal. So what can you call this matrix? This is a what? 1 by 3 matrix. Why? Because we have 1 row and 3 columns, okay? But this is a row matrix. When you have just 1 row, it is a row matrix. Now a column matrix is similar. When you have just 1 column, what do we call this? This is a 3 by 1 matrix because it has 3 rows and 1 column. Okay. Then a null or zero matrix. Null in mathematics means it's zero. It's empty. Would I say empty? No, it's not empty, but you have just zeros as the element in the matrix. So it's referred to as your null or zero matrix. Now a single element matrix, from the word, it has just one element in the matrix, right? And then you have your square matrix when the row is the same as the column. The number of rows is the same as the number of columns. This is a 2 by 2 matrix. So this gives you a square matrix. We have the diagonal matrix. This is a case where you have a square matrix. Square matrix, remember, means you have the same row and the same column, right? The number of rows is the same as the number of columns. So in this case, when the leading diagonals are not zero, but every other values are zero, it's called a diagonal matrix. So every value is zero except the leading diagonals. But for unit matrix, for these diagonals, they become one. That's when it's a unit matrix. Take note of the differences. The diagonals, leading diagonals are one. Okay. Now, equal matrix is when you have maybe two or more matrices given to you and their elements are equal. So in this case, you see that A11, this means the first row and the first column, is the same as its corresponding, which is 5. A12 is the same as 4. A13 is the same as 6, and it goes on like that. Okay, now that we know the types of matrices, do not forget to subscribe, like, share if you enjoyed this video. In the next class, we'll be treating how to add and subtract matrices. Okay, to recall what we've done, we said that matrices are just tables of numbers. So you represent these tables as a matrix. So imagine your Microsoft Excel or your Google Sheet right now. The way you have your rows and column, that is how it is with matrices. We mentioned the types of matrices that we have. We also told you how you can call your matrix, how it's said 3 by 2, 2 by 3, making sure that the number of rows is mentioned before the number of columns. So it's called 2 by 3 or 2 times 3, right? When you have 2 rows and 3 columns. Of course, we learned the types of matrices. So anywhere you see it, you know what type of matrix you're dealing with. We'll see you in the next class. I'll see you in the next class. Until next time. Bye.